Hi everyone, and welcome. Today, we're diving into the fascinating world of Boolean algebra and exploring two powerful tools called De Morgan's laws. These laws are essential for simplifying logical expressions and understanding digital circuit. De Morgan's laws come into flavors, the first theorem and the second theorem. Let's start with the first one. De Morgan's first theorem states, the complement of a sum is equal to the product of the complements. Let's break that down. Imagine we have two inputs, A and B, going into an OR gate. The output is a plus B now. If we take the complement of that output, we write it as a plus B. De Morgan's first theorem tells us that this is the same as taking the complement of A, which we write as a prime, and the complement of B, written as B prime, and then ANDing them together. So, A plus B is equal to AB. Let's prove this with a truth table. As you can see, for every combination of A and B, the values of AB and AB are identical. This confirms De Morgan's first theorem. First, let's consider when A is 0 and B is 0. In the OR gate, 0 plus 0 is 0. The complement of 0 is 1. So, AB is 1. Let's try another case. A is 0 and B is 1. 0 or 1 is 1. The complement of 1 is 0. So, AB is 0. Do the same for the remaining two conditions. Now, let's look at the other side of the equation. A prime is 1, and B prime is also 1. 1 and 1 is 1. So, AB is also 1. A prime is 1. B prime is 0.1 and 0 is 0. AB is also 0. Again, they match. As you can see, for every combination of A and B, the values of AB and AB are identical. This confirms De Morgan's first theorem. De Morgan's second theorem states, the complement of a product is equal to the sum of the complements. We'll use two inputs, A and B, and see how the theorem works. We have two inputs, A and B, going into an AND gate. The output is of. Now, if we take the complement of that output, we write it as of. De Morgan's second theorem tells us that this is the same as taking the complement of A, which we write as a prime, and the complement of B, written as B prime, and then ORing them together. So, of is equal to A plus B, or A plus B. Thus De Morgan's second theorem is verified.